Hi class, this is page 2 of section 4.4, complex numbers. Also, it's listed as part B under the assignments, I believe, in wisdom. So what we're going to talk about today are operations with complex number. First of all, a complex number is any number that can be written in the form a plus bi, where a and b are real numbers and I is the imaginary unit. Keep in mind, I squared is -1. A is called the real part and b is called the imaginary part. So in order to add or subtract complex numbers, what I would recommend you doing is to line them up vertically. So you would set it up as a plus bi plus c plus di, and then you would simplify. Obviously we can't simplify here, but you would just simplify underneath. You would add here and add here, and you would have your complex number. If it's subtraction, remember that the minus goes with everything in the second parentheses. So when you set this up vertically, it would be a plus bi minus c minus di. Distribute through the negative. When we multiply complex numbers, we're going to use FOIL, and my method of FOIL will look like this. I take the a plus bi and I write them out vertically. Now foiling means that you're multiplying everything in the first parenthesis by everything in the second parenthesis. So I'm going to put c times c plus di beside both the a and the plus bi. And then I am going to distribute. So I would have a c plus a di, and I'd have plus b c I plus b d I squared. Now, you would combine these like terms, but I want you to remember that this part right here would be the same as saying minus bd, because I squared is -1. Dividing complex numbers, in order to do that, we first multiply the dividend and the divisor by the complex conjugate of the divisor. The complex conjugate of the divisor is just taking this and making it a minus bi. That's what we would multiply by on the top and the bottom. So a plus bi and a minus bi are complex conjugates. Again, all that changes is the sign in the middle. The product of complex conjugates is always a real number. And that's what we want in the denominator. We can't have a complex number in the denominator. We have to have a real number, just like we can't have 0 in a denominator. So what you use is the definition for the sum and difference of terms to simplify the divisor, meaning you have a plus bi times a minus bi. That's the sum and difference of two terms. And all you have to do, you don't have to even FOIL this all the way out, is you're going to multiply a times a minus bi squared. That would become a squared plus b, because the I squared is -1. You use the definition of I squared and the FOIL method to simplify the dividend. The dividend is your numerator. So you take c plus di, multiply it by a minus bi. So again, write these vertically, C plus DI, multiply them both by A minus BI, A minus BI, and what you will have will be AC minus BCI plus ADI minus BDI squared. Remember that this will end up being plus BD. Now the letters each represent numbers, and so you'll see how the answers should look when we do these next examples. But these are the operations that we use with complex numbers. Refer back to these as needed when you work the practice problems, as well as refer back to the examples we're going to do now. Okay, so our first two are using the properties of addition. So I'm going to rewrite this first one as 6 plus I plus 4 minus 5I. And I'm going to simplify. 6 plus 4 is 10. I, or 1I, minus 5I would be minus 4I. On H, don't forget that we have to distribute the negative, so we will have 8 plus 3I minus 6 plus 2I. 8 minus 6 will give us 2. 3I plus 2I will give us 5I. So there's addition and subtraction. For multiplication, we're going to FOIL. Notice that this one is the sum and the difference of two terms. And remember how I said to do that? You take the first two terms together, so you'd have 2 times 2 minus I times I, which is I squared. 2 times 2 is 4, minus a negative 1, since I squared is a negative 1, and 4 plus 1 gives us 5. So we just took, by multiplying, these are conjugates also, multiplying them together, and we get a real number. On the second one, on J, write 2 minus 5I, and beside both we're going to multiply a negative 4 plus 2I, a negative 4 plus 2I. So we will have 2 times negative 4 would be negative 8. 2 times 2I would be plus 4I. Negative 5I times negative 4 would be plus 20I. Notice I lined it up under the like term. And negative 10, or negative 5 times 2 would be negative 10I squared. Remember, I squared is negative 1, so make that a plus 10. Just get in the habit of any time you see I squared, it's negative 1. So you change your sign of what you had. If we had 20I squared and there was a positive 20, let's see, I think I wrote that wrong. This should have been no, I didn't write it wrong. This would have been a negative 10. I think I just screwed up a little bit. No, I didn't. Negative, this would be 20I. Negative 5I times negative 2I would be negative 10I squared, but that becomes positive 10. Simplify, negative 8 plus 10 would be 2, plus 4I plus 20I would be 24I. Now, the bottom two, we're still going to be using multiplication, but we have to multiply the top and the bottom both by the conjugate of the bottom. The conjugate of the bottom would be 3 minus I. So we multiply the top by 3 minus I, and we multiply the bottom by 3 minus I. And I like to go ahead and group my terms in parentheses for when I FOIL. So on the top, we would have 5 times 3 would be 15 minus 5 times I is 5I. On the bottom, when you multiply conjugates, notice it's the sum and the difference of two terms. So you take the first two together, 3 times 3 is 9, minus I squared, so that would be plus 1. We would have 15 over 10 minus 5I over 10. And we would want to reduce these. Those are both divisible by 5, so we would have 3 over 2 minus 1/2 I. Or you could write the answer. Let's just say that that's the preferable form right there, because that gives the real part and the imaginary part. All right, so lastly, the conjugate of 2 plus 3I is 2 minus 3I. So we take and we multiply the top and the bottom by 2 minus 3I. 2 minus 3I. Now, remember, I did these vertical, but I'll tell you that FOILing is the same thing. If you'll take your first term and multiply it all the way through, so you'll have 3 times 2 would be 6. 3 times negative 3I would be minus 9I. Then do your negative I times 2 would be minus 2I. Your negative times a negative would be positive 3I squared. So, and I squared is negative 1, so make that a minus 3. The top will simplify to 3 minus 11I. Now on the bottom, remember that they're conjugates, so it's 2 times 2 is 4 minus 9I squared, so that would be plus 9. So we would put a 13 as our denominator under each part, the real part and the imaginary part. And now you've learned how to do the operations with complex numbers. I hope that you find the practice easy by following along with these examples. And don't forget about Khan Academy and YouTube to search for working with complex numbers. You really might find some extra reference material that would be super helpful. All right, you guys have a great day, and I'll see you next time.